All right, so we're going to do the same problem again using the node voltage method. What I want you to see here is the node voltage method is going to be a lot easier because there's no KCL when you have a voltage source. So there's no KCL here and there's no KCL here. So what you're going to have is that V1 is 1.35 volts and you're going to have that V3 is 10 I naught. So that means we only have to do KCL at node 2 and then we only have to write the constraint equation because of that dependent source. So now that the constraint equation is based upon V1 and V2, so the constraint I naught is going to equal higher potential V2 minus lower potential V1 divided by 5. That's Ohm's law. Resistors always drop voltage, so the current flowing to the left means V2 is a higher potential than V1. Thank you for sharing the live. Thank you for following. Thank you for tapping the screen. Doing all the things that will get us out on the FYP and keep us on the FYP. We got 14 people hanging out inside of here with us. 761 looking out from outside the STEM Cool Kid Club. We love you just the same. You're not getting the AC, you're not getting the heat, you're not getting the DJ or the bar, but we're just glad you're looking anyway. Okay, so now KCL at that middle node is going to be, I'm going to do all of them out. It doesn't really matter. I'll have V2 minus V1 over 5 plus V2 minus 0 over 20 plus V2 minus 10 I naught over 5 equals 0. We're going to have current out plus out equals in. This ends up being, I can get this down to 2 equations and 2 unknowns. For the level 400 E&M course I'm going to take, you better be excited for some E&M. E&M is not my ministry, Rashad. You knock yourself out, buddy. Love it, love it, love it. I don't mess with no E&M. All right, so now we're going to go back into Maple and put in these equations. Then we did the exact same problem again, same circuit, using the node voltage method or KCL, Kirchhoff's current law. And equation 1 is V1 is 1.35 volts. V3 is 10 I naught volts. That is our dependent source. I naught is V2 minus V1 divided by 5. And the KCL equation at node 2 is V2 minus V1 divided by 5 plus V2 over 20 plus V2 minus V3 divided by 5 equals 0. And when you solve those 4 equations, you should get the exact same I naught. So I naught is negative 1.35 amps again. V1 is 1.35 volts. V2 is negative 5.4 volts. And V3 is negative 13.5 volts. This is an example that shows that whether you do KCL or KVL, mesh current method or node voltage method, you should get the exact same answer. So next we are going to confirm this by putting these values on our circuit and showing that you get the same thing. Now, using the solutions for the node voltages, I'm going to have 1.35 for the 1.35 source. 10 times I naught is going to be negative 13.5. So that means, once again, those are both going to be delivering power. Then the voltage for the 20 ohm is going to be V2. So that is going to be 5.4. And so the current is going to be voltage divided by resistance. And you can see that power is the same as what we got before. And then for the top 5 ohm resistor, it's going to be V1 minus V3, or that is 1.35 minus negative 13.5. And once again, the current is going to be that voltage divided by resistance. And that's 44, which is exactly what we got before. And now we're going to do our next 5 ohm resistor, which is going to be V1 minus V2, V1 minus V2. So that's going to equal 1.35 minus negative 5.4. And so that's going to equal voltage divided by resistance. And we get the same power for that one. And then we need to do the one on the right, which is going to be V3 minus V2, V3 minus V2, or V2 minus V3. I try to stick with the negative, the positive numbers. That's why I decided it's going to be equal to negative 5.4 minus negative 13.5. That's 8.1. So the current is going to equal that 8.1 divided by 5. All right, so we have all of our resistors, and so far the table is matching. So the only way to get the currents for the sources using only the node voltages is to use KCL. So that means I want the current for the 1.35 source. I have to do V1 minus V2 over 5, or the current through that 5 ohm resistor. So that's going to equal this current plus the current on the top, which is this one, and that's 4.32. But it needs to have a minus sign because it's delivering power. And then for the 10 I naught, you have to do the same thing. So it's going to equal the sum of the current across the top plus the current on the bottom right. So actually it's this one. Let's do the part here. So it's going to equal this current plus this current, and that's 4.59. And so once again, we have shown that power delivered equals power absorbed, and that all the values do match, because this once again is essentially 0.